Hi and welcome to Jnu Igidr's classes. Today we are going to be doing higher order differential equations. Let's start off with a very basic sum. We are given here 5 functions or equations and we need to find particular integrals of each equation. Before proceeding further, let me tell you one basic simple process that we can apply for all. Let us assume a second order linear differential equation with constant coefficient. This is a basic second order linear differential equation with constant coefficient and a constant term. In order to proceed, we will discuss a very simple process. Let y equals to a constant. Now the motive behind this is when we differentiate y, we get y double dash equals to y dash equals to 0. Now all we need to do is put this in this function and it comes to a to y equals to b. Thus y equals to b by a. Thus the desired particular integral becomes yp equals to b a2. We need to also mention that a2 is not equals to 0. Let's see how to do the first question. This is the first equation we have. Let's see how to do this. Let y equals to a constant c. Therefore y dash equals to y double dash equals to 0. Now we will put this values in this function. Thus it comes to 5y equals to 2. Notice this and this part of the equation becomes 0. Thus yp equals to 2 by 5. Notice this is just like our equation b by a2 and a2 is not equals to 0. We can also discuss an economic rationale, that is, this process of finding the value of yp involves the condition y dash t equals to 0. From this rationale we can consider that the value of an intertemporal equilibrium becomes self-evident. Now let's do the next question. I'll clear the screen so that you can see the question. Similar to the previous question, we have another equation y dash double dash t plus y dash t equals to 7. Notice there is no y term in this question. Let's see how to do this one. In this, the value of a2 equals to 0. Now how will we do that? We mentioned that a2 has to be not equals to 0 in order to follow the previous process. Don't worry, in this we have another process to find out the particular integral. For this case, we will take let y equals to kt. Thus y dash becomes k and y double dash becomes 0. Now all we need to do is put these values over here. Now the equation becomes k equals to 7. Notice we need a t term for a particular integral, so we multiply t on both sides. Kt equals to 7t, and from kt we know is equals to y. Therefore y equals to 7t, and this is the particular integral required for this question. I'll show you a generalized form of how to do this. I have taken a generalized equation for your ease. In the last question we did not have a constant a1, thus we only obtained k equals to 7. Now what to do in this case? Similarly, let y equals to kt, therefore y dash equals to k and y double dash equals to 0. and upon substitution we will get a1k equals to b. Thus k equals to b by a1. Similarly, we will multiply t on both sides, giving us kt equals to b by a1, or yp equals to b by a1 into t. And this is the rule that we will follow in cases of where a2 is equals to 0. Let's solve another question. Now let's jump to question number E. I'm leaving number C and D for you to try. The reason I'm doing number E because it is of a different type. For your ease, number C and number D will be done in the same way as we did number A. Let's jump right into this question. Y double dash t equals to 12. Now how to do this sum? Both a1 and a2 equals to 0. Let's see. This also has a simple process. For this, we will assume that the value of y is kt square. You'll understand why I am taking this. Now y dash becomes 2kt and y double dash becomes 2k. Now again we'll put these values over here. Notice since y and y dash are missing, we'll only put the values of y double dash. I'll do it on the side so you can see it easily. Therefore the value comes 2k equals to 12, or k equals to 6. Now in order to get y, we need to multiply t square on both sides. Therefore kt square equals to 6t square. Therefore yp equals to 6t square. There you have it. It's that simple. Notice, since in the last two cases we have taken y equals to kt and y equals to kt square, this can be represented as a moving equilibrium. The reason being, only in the first case y that is, in the first case where y was assumed as a constant, but in the second two cases we assume y equals to kt and y equals to kt square. This is regarded as the moving equilibrium, just because the value of y changes with respect to t. Notice in the second case we have y equals to kt, but the value changes further for the next case. I've written down the answer to the rest of the two questions that I allowed you to do that. Please check your answer with mine. Don't worry if it does not matches. Check again your calculations and I am sure you can do it. In the next video, we'll be dealing with complementary function. So stay tuned, like, subscribe and press the notification button.